Alright, today we're doing exact values of trig functions using double and half angle identities. You will want to get these identities memorized to the best of your ability. I will go through how to prove the first one as well. The first one I'm going to do is the sine of the double angle. So the sine of twice some angle. I think you guys would agree that the sine of twice an angle would be the sine of the angle plus itself. So in other words, the sine of an angle plus another angle. And you've seen an identity for that already, the sine of A plus B. Alright? You guys know that the sine of A plus B equals the sine of A times the cosine of B plus the cosine of A times the sine of B. So using that identity, but with thetas, this will equal the sine of theta times the cosine of theta plus the cosine of theta times the sine of theta. Those are like terms. Add them together. 2 sine theta cosine theta. There is your identity for the sine of the double angle. So the sine of the double angle equals 2 sine theta cosine theta. Definitely one you'll want to know how to prove come test time. It's a very simple one to prove. It uses this identity. It should be pretty simple. I could go through the proofs of the other ones. I won't do that in this video, but I will go ahead and give you the rest of them. Okay. The cosine of the double angle is equal to cosine squared theta minus sine squared theta. So there's one of them. You'll see 3 identities for this one in there. The cosine of the double angle could also equal 2 cosine squared theta minus 1. And where that comes about is we replace sine squared with 1 minus cosine squared. So if this would replace this, you get cosine squared minus 1, so there's the minus 1, minus another cosine squared. Well, cosine squared minus a negative cosine squared would be 2 cosine squared, and that's how you get 2 cosine squared theta minus 1. The third one for the cosine of the double angle is 1 minus 2 sine squared theta. And we get to that by doing a very similar simplification. We replace cosine squared with 1 minus sine squared theta. So 1 minus sine squared minus another sine squared would be 1 minus 2 sine squared theta. So you'll see 3 identities for the cosine of the double angle. There's one, there's a second one, and there's a third one right there. Okay? So 3 identities for the cosine of the double angle. The tangent of the double angle is equal to 2 times the tangent of the angle over 1 minus tangent squared of the angle. Again, those are your 3 double angle identities. I'll show you how we can use those here with my next example. Okay. For example, let me give you this one. If the cotangent of some angle equals 4, and that angle is in quadrant 3, let's find the sine of twice that angle and the cosine of twice that angle using identities, using exact values. Right? So if the cotangent of some angle is equal to 4, I draw a picture. Put it in quadrant 3, 1, 2, 3. Cotangent, well, tangent is opposite over adjacent, so cotangent would be adjacent over opposite. So this would be negative 4, negative 1, or negative, negative. Okay? Here's my angle A. Using Pythagorean's theorem, 16 plus 1, 17, so this would be the square root of 17 right here. Then, to find these answers, just simply use the double angle identity. The sine of twice an angle is 2 times the sine of A, cosine of A. Well, what's the sine of A equal in this picture? Sine is what? Opposite over hypotenuse, so negative 1 over root 17. What's the cosine of angle A? Cosine is adjacent over hypotenuse, so negative 4 over root 17. Put that 2 over 1. 2 times negative 1 times negative 4 would be 8. And then 117 would simply be 17. So the sine of twice this angle is 8/17. There's your first answer there. Then all I do is I do the cosine of the double angle formula. So the cosine of 2a, pick any one you want. I'm going to pick the squared one, so the cosine squared a minus sine squared a. Again, the cosine of angle A would be negative 4 over root 17, but I got to square it. And the sine squared of angle A, sine is opposite over hypotenuse, so negative 1 over root 17, but again I got to square it. So this squared, that'd be 16, that'd be 17, because the square root of something squared is that itself. Negative 4 times itself is 16, so I got 16/17 right here. This would be 1/17, so minus 1/17, answer 15/17. So the cosine of the double angle equals 15/17, the sine of the double angle would equal 8/17, and you never even had to figure out what the angle was. You can just use the double angle identities to help you get there. So that's kind of the idea how double angles will work for you with your homework. Let's see, I got to do half angles yet. The first one I'm going to do is the cosine of theta over 2. That's what I'm going to try and get first. I'll show you how to derive it. Okay. We just did a double angle formula, so what I'm going to do here is I'm going to take the cosine of 2 times theta over 2. So it's kind of like a double angle identity. It's the cosine of twice some angle. And I'm going to use the fact that, you know how with the double angle identity we had the cosine of twice some angle is equal to 2 cosine squared of that angle minus 1. So again, this was like my A in that double angle identity. So the cosine of twice angle A is equal to 2 cosine squared A minus 1. Now I think you guys would agree 2 times theta over 2 is just theta. So I have the cosine of theta equals 2 cosine squared theta over 2 minus 1. Now I'm just going to solve for this half angle to show you how the proof comes about, or how the identity comes about. So add 1 to both sides. Cosine of theta plus 1 equals 2 cosine squared theta over 2. Divide both sides by 2. So cosine theta plus 1 all over 2 equals cosine squared theta over 2. And then square root both sides. So your identity is a positive or negative cosine of theta plus 1 all over 2 equals the cosine of the half angle. So there's your first half angle identity. A cosine of half of an angle is equal to this amount right here. Okay? You take the cosine of the angle, add 1 to it, divide by 2, and then you square root it. So again, there's the proof of the cosine of the half angle. We could go through the other ones similarly, but I'll just go ahead and give them to you. Sine of the half angle is equal to plus or minus the square root. Very similar, except it's 1 minus the cosine of theta over 2. And then the tangent of the half angle is equal to the square root. I just take this divided by the sine one, so I get 1 minus cosine theta over 1 plus cosine theta. So those would be the other identities. So you have 6 identities today. You have 3 double angle identities and 3 half angle identities that you will use to solve different sorts of problems. You can use these identities to do proofs as well. Let's say, for instance, I gave you this. Sine squared b, sine b plus cosine b squared equals the sine of twice b plus 1. So you'll see a double angle identity in that verification. This is the more complicated side right here, so I'm going to square it, which would result in a FOIL. So sine b plus cosine b plus another sine b cosine b. So I get sine squared b plus sine b cosine b plus another sine b cosine b plus cosine squared b. notice these are like terms. So I got sine squared b plus 2 sine b cosine b plus cosine squared b equals the sine of 2b plus 1. I got a sine squared plus a cosine squared, that's 1. So I got 2 sine b cosine b plus 1 equals the sine of the double angle plus 1. And this is where you just have to recognize your identities. Recall the sine of twice angle b. The sine of twice some angle is 2 sine cosine. That's what we have. 2 sine cosine, that is the double angle identity right there. These two things are equivalent, so I can say the sine of 2b plus 1 equals the sine of 2b plus 1. And done. Okay? There's a proof, there's a verification. That'd be something from Learning Target 7.1 that might show up on a test. So again, using the identities in different ways, just getting to know the identities is the important thing. The more you practice with them, the better you get. Trying to think if I want to give you a half angle. We'll do one half angle situation here. Let's say I said find the exact value of the sine of 67.5. Well, 67.5 is definitely not one of the angles that you know, but it is exactly half of one of the angles that you know. And it'd be the sine of, I believe, 135 divided by 2. 67.5 is the same as 135 divided by 2. So using your half angle identity, this would equal a positive or negative square root 1 minus the cosine of 135 all over 2. Going down here, 67.5 we know is in the first quadrant, so I don't need to worry about the plus or minus anymore. Anything in the first quadrant is going to be positive. So I have the square root of 1 minus, what's the cosine of 135? It's 45, quadrant 2, so it'd be negative root 2 over 2. And that's all over 2. Simplifying this, not very much fun. But when you divide something by 2, you could multiply everything by a half. If you take 1 times a half, you get a half. So I have the square root of 1 half. If I take this times a half, I get root 2 over 4, and it becomes plus actually. If I make that a common denominator, 1 half would become 2/4. So 2/4 plus root 2 over 4. So really you get 2 square root 2 plus root 2 all over 4. And if you square root the top of that fraction, you can't simplify it, so it's the square root of 2 plus root 2. If you square root the bottom of that fraction, the square root of 4 is just a regular 2. So this would be your final answer for the sine of 67.5. What I do to check too is I would type this into my calculator, make sure I'm in degree mode, see what decimal that is. Then I type this into my calculator, see what decimal that is, and make sure they match. That way I know I did all my simplifying correct. Alright, so there's an example of kind of using a half angle. A little bit tougher because you do have fractions involved. Okay. For your practice, I'll send those out later. I don't have that up right now.